essential nutrient. I'm not aware of any individual that has a genetic tendency to not be able to absorb phosphate. If they couldn't absorb phosphate, they would. There's lots of consequences for having even low phosphate concentrations. There's a lot of medical conditions that can occur if you have low phosphate in your body. And if somebody can't absorb phosphate, they would. I can't specifically say, but I would assume that that person would have significant medical difficulties if they can't absorb phosphate.
Okay, there's a terminology issue here. One is food grade. And preservatives can fall into the category of food grade. Yellow number 5, for example. I'm sure that the community, because of its turnout here, has expressed a deep concern that what's in their water is not being processed properly, as well as the idea that if we solve a pH issue, we can resolve this chemical entirely. Now that may not suit well with the salesperson for this particular company. However, we have had reason to be concerned because when people had stopped drinking this water, some of the health problems that they had went away. So I am asking the question, what happens if, and I don't have any data on this, I've done some research, but what happens if there is an inability for somebody to process this phosphate? Yes, it breaks down. Ortho, for those that don't know, is a combination. It's just the combining of phosphates.
No, that's a poly.
Then in its irregular form, the triphosphates, or in all those different forms.
Well, poly is the
combination.
Right. Or
Correct.
you said ortho.
I said ortho.
So I had to correct you there, but go ahead.
Please, thank you, and I appreciate that. I meant to say ortho polyphosphate,
right.
But that,
go ahead.
I wanted to remind that when I am asking the question about how a phosphate enters the cell, it has to do it in an organic way. It has to be broken down. There is the enzyme process. What I don't understand is what the process is with this formed. It's a new form. It's not natural. Maybe food grade by your definition, although there may be an issue with that because of who claims this is food grade. But I'm not going to address that issue. I want to know what the process is of the body when it breaks it down, if there's somebody that has that inability to break it down into a simpler form or a form that can be utilized and it doesn't interrupt the uptake of water in its normal electrolyte process.
So I guess, I mean, again, you're saying that the body, there's going to be an individual who can't break down phosphate?
Well, first of all, I think we need to make the distinction between ortho and poly. So, as I understand the question, the fact that there is a poly component, which is, different than just a singular phosphate, but rather a polyphosphate, if somebody were to ingest that and digest it, does it take additional energy to break that poly into an ortho? And could that, what if somebody didn't have the ability to do that?
Well, I mean, it's going to naturally happen in the stomach. The stomach actually is quite acidic, and these phosphates and those forms actually hydrolyze in acidic conditions, but also the body contains enzymes that are called phosphatases that will break those down. Now, polyphosphates actually are produced in cells themselves. Again, we talked about how just ATP is a perfect example. It's just adenosine triphosphate. It's a polyphosphate that the body uses as an energy source, and it's a critical chemical for the proper functioning of the human body. The cells individually will produce chain lengths of polyphosphates that are even much longer than 3 within the cells, and then break those down later for energy purposes. So I guess I think what he's trying to get at is what if there are specific, genetic defects or possibly that somebody might not have a process to handle those particular polyphosphates themselves, and I probably have to go and do some additional research to see if there even exists. I'm not even sure if that does exist.
So naturally it would be, when poly hits water, it's going to break down to some extent. When it hits your stomach, it's going to naturally break down.
Correct.
And through enzymatic activity, it will then completely break down, correct?
Correct.
Does that answer your question?
Yeah, but we've got, the visual that I see is when it hits the pipes, it coats it. When it hits your pipes, what does it do? The chelating factors, when you have other phosphates that combine metals together, in this case grabbing is the word that's used, I don't have any disclosure of what happens in this. You're saying it's a phosphate, you qualify it as that, But this is not found in nature. We did a little soil sample testing. This is something we did months ago. And we found that bottled water, and we took tap water. We poured the water into identical pots and soils and found that we had, to our surprise, to add more water to the pot with the Ortho Poly Phosphate in it, which meant something to me, that the water molecule wasn't being absorbed into the soil material.
Did a lab, you know, Dina, and I appreciate the test you've done, but truly, to consider data like that, it should be in a controlled environment, in a laboratory, by a...
That's, I think, we're losing focus.
No, I think that's where...
We want pH...
Hold on, Dean, please let me finish. I agree it is where we're losing focus, but to the extent we have data, we have to use the best data. And, you know, frankly, that kind of thing, to be presented as factual information, should actually be tested in a qualified lab and then presented as factual data. That's all I'm saying. I don't discount it. If it happened, I believe it's true. But let's please, if it's data that you're going to use for analyzing water quality, it really should be lab tested data.
While we're on the subject of data, though, how come we are putting in a substance that hasn't been adequately tested for our safety as human beings, long term? Small exposure, yes, but long term. There has been no data given to us on that issue. And I agree. Maybe that is a future study, a good, valid future study.
So let me go back and hit on a couple points. You know, we're coming back to this issue of long-term test data for the product. Now, let's revisit this. The product is made up of various phosphates, all of which are food grade. And it is a combination in certain ratios of those various phosphates. Is that true?
Yes.
And are all of those individual phosphates, is there toxicology data on each of those individual components?
Absolutely.
Okay.
If you go, I mean, the FDA has done extensive testing on a lot of these types of phosphates, where they've done mutagenicity, they've done chronic studies in rats, they've done teratology studies to see if these types of compounds can cause birth defects. There's a plethora of data out there. I mean, a lot of it is a little older because a lot of the toxicity issues with phosphate were just addressed back in the 70s when they determined its GRAS status. So there's a lot of toxicology data that's done on all the components of this particular product.
Mm-hmm.
Okay. And now, are they combined in some way to make some, unnaturally occurring molecule, or is it components that are basically put together similar to a recipe? What's the difference there?
Who are you asking the questions to?
To you.
Okay, so ask me again one more time. I apologize.
How are these phosphates? I mean, is it just quantities of different phosphates put together and blended up, kind of like, if I were
baking? Like a recipe. Yeah.
Okay. So. All right, I'm just trying to get at the fact that we have some unnatural substance out there. As I understand it, what we have is a combination of food-grade phosphates.
Right, NSF certified food-grade phosphates, absolutely.
Okay.
Absolutely. I got to tell you, we had a representative from China come and offer us phosphates. And I just wanted to let you know that the difference in cost was about maybe 10% of what we're currently buying from North American phosphates. Mm-hmm. And Jerry was pretty adamant about this stuff. I mean, if we had an opportunity to, be more competitive price-wise, then, why shouldn't we look at it? So we looked at it, and we found that it just wasn't, and I can't say whether these particular phosphates at the time it was offered to us were NSF certified, because I think at that time there were only like 3 companies that were NSF certified at the time. I don't know if this was, these were one of them, but Jerry told me this himself. And they tested it. They tested them very thoroughly, and they found that they just didn't work the same way the North American phosphates work. So we just passed on it. I mean, we've kept our formula for the last 20 years, absolutely the same. We haven't messed with it. I mean, it is what it is, and it's 100% certified, and it's North American longer chain phosphates. And, that's part of our technology that we've been able to develop. And it just strangely, oddly enough, it's something exclusive of North American phosphates.
How do you get North American phosphates?
They're mining companies that get it from U.S. and Canada.
Okay.
And then, it's raw material, then they process it, through the, whatever they do, I don't know.
Yeah.
Can I ask a question? Because it's come up a couple times. This is Chris, and I'm a board member here. And thanks so much for your patience on this call. We really appreciate the time you're taking in educating everybody. But one question I have, this bottled water issue keeps coming up. And isn't it true that drinking water in municipal systems go through far more scrutiny than bottled water?
Absolutely correct. You can Google that and find out that yourself. Absolutely.
Well, I did a different test with the creek water, actually, where we watered the garden with the water from the Baca unfiltered and witnessed what that did to the health of our plants. And we then also watered it with the creek and got to see the difference between completely untreated water, which maybe even had a little extra rust in it because of the pipes under the roads, but still was mostly completely untreated and random, in its pH a lot of the time, but just by virtue of being untreated appeared to have a much more synergistic effect with the soil and the plants and with us drinking it than water that has been so treated and so tended to and so overly controlled to the point where it's, water and something else. It's not water anymore.
All right, we'll come back to that.
That's what we're talking about.
Okay, we'll come back to that. Hold on. We've got, let me get to this. Go ahead. I'm sorry, go ahead.
Yeah, I'm happy to see the discussion moving in the direction of really trying to inform everybody. Pleased to have the representative. It does seem to be nice if we had a real environmental chemist in the room. I don't think we do. We're talking about phosphate with from what I understand, limited understanding, Monsanto, of course, which evidently is not involved here, but they do produce Roundup, which is an herbicide, active ingredient glycophosphate, which sequesters essential minerals, nutrients, and keeps the plant from being able to live. So there are different forms of phosphates. And to assume that we understand it, I think, is maybe a little bit, a big leap.